Myself, Harshal Nilkanta Nemade, lecturer in Mechanical Department at Praveen Patil College of Diploma Engineering and Technology. Topic: Behavior of ductile material and brittle material under tension. Behavior of ductile material under tension. This is the diagram. So, there is one graph, stress strain. We will see one by one what is OA, AB, BC, CD, DE, EF. At F point the material breaks. How it is break we will see. O to A. O to A is a proportional limit where stress is directly proportional to the strain. Therefore, sigma is equal to capital E multiplied by small e, where E is equal to capital E is equal to Young modulus or modulus of elasticity given by Newton per mm square. Second, A to B. A to B, if the load is increased beyond A up to B, the material behaves in elastic manner. That on removal of load, the whole deformation will vanish. The value of the stress corresponding to the point B up to which the material behaves in elastic manner is called as the elastic limit. So in diagram you will see that O to A, where stress is directly proportional to strain, it will be the straight line. Okay, but at A and B the material gets little deformed and it will be vanished, and the time there will be the elastic material in the material. B to C. Point C is called upper yield point. At the point there is an increase in strain even though there is no increase in stress load. Yield means change in shape or permanent set. Permanent set means what? At C point when material get increase, it will not regain its original shape and size. It will permanently set at that point. From C to D, point D is called as lower yield point. After yielding has chased at D, further stress and strain can be obtained by increasing load. Strain is more at the point D than C. Okay. So there will be the neck formation in the material. When we are pulling the material from both the side in tension, at the middle there will be the neck formation and that will be a lower yield point. D to E. Point E is called as yielding point and stress is maximum at the yield point. This is also known as ultimate or maximum load point. Last, E to F. As the elongation continues, cross-section area becomes smaller and smaller, and ultimate the specimen is broken at the point F into two pieces, giving cup cone type of the ductile fertilier. At F point stress decrease and strain increase, hence the point F is called as breaking point. So this is a behavior of ductile material under tension. Now we will see behavior of brittle material under tension. This is figure. In this, directly O to A and after A to B and material gets filled. So O to A approximately proportional limit. In this case of brittle material, we can't say here the stress is directly proportional to the strain. Okay. What happen when we pull the material, brittle material, first it form a crack in a material and directly it gets break. It doesn't gives any neck formation in the material. In brittle material we don't get any neck formation. Second, A to B. Point B is called as breaking point or fracture. Stress and strain both increase. Brittle material develop internal crack first and then the crack reach up to the surface. And after surface, when it reach up to the surface, the material gets break at the B point. So B point is known as breaking point. Example of the brittle materials are wood, glass, cast iron, ceramic and concrete. Now we will see the numerical on the The following observations were made during a tensile test on the mild steel specimen of 40 mm in diameter and 20 mm long. Elongation with 40 kN load within limit of proportionality, delta L is equal to 0.0304 mm. Yield load is equal to 161 kN. Maximum load is equal to 242 kN. Length of specimen at fracture is equal to 249 mm. Determine Young modulus, yield stresses, ultimate stresses, percentage elongation. Now solution. First, given data, what they have given, read the question. The following observations were made during the tensile stress on the mild steel. So tensile stress on the mild steel specimen, which is diameter is 40 mm they have given and 200 mm length. Okay. After that load they have said 40 kilonewtons. So in Newton multiplying 10 raised to 3. So it will be 40 into 10 raised to 3 Newton. Delta L they have given 0.0304 mm. Yield load is equal to 161 kilonewton is equal to 161 into 10 raised to 3 Newton. Okay, maximum load 242 kilonewton to Newton, 242 into 10 raised to 3 Newton. Length of specimen at the fracture is equal to 249 mm. So after given data, what they have asked to determine Young modulus, yield stress, ultimate stress, percentage elongation. So we know cross sectional area of circular rod. A is equal to pi by 4 multiplied by d square. A is equal to pi by 4 multiplied by d value 40 square. So A value will be 1256.637 mm square. After getting area, continuing the next page, we will find Young modulus. Young modulus is given by E is equal to P by A multiplied by L is equal to delta L. So P value is 40 into 10 raised to 3 divided by A value 1256.637 multiplied by capital L value 200 mm and delta L value is 0.0304. Calculating all these values, I get capital E is equal to 2.09 multiplied by 10 raised to 5 Newton per mm square. This is the value of Young modulus. After Young modulus, they have asked yield stress is given by yield load upon area. Yield load value is 161 multiplied by 10 raised to 3 divided by 1256.637 area. So I will solve. I will get yield stress is equal to 128.12 Newton per mm square. After that, third thing they have asked ultimate stresses. Ultimate stresses is equal to maximum load divided by area, or you can say ultimate load. Instead of maximum load, you can say ultimate load. Okay. So maximum load they have given 242 multiplied by 10 raised to 3 divided by 1256.637. So after solving, I will get ultimate stresses is equal to stress, not stresses, stress. Ultimate stress is equal to 192.58 Newton per mm square. And last thing they have asked percentage elongation. Percentage elongation formula is increase in length divided by original length multiplied by 100. Increasing length is 249 minus 200 divided by original length is 200 multiplied by 100. After solving, percentage in elongation is 24.5%. So this is your numerical. If you have any doubt, you can comment or contact. Thank you.